Ever found yourself staring at a beautifully organized workspace, a digital canvas where projects flow seamlessly, and wondered, what's the magic behind this? I'm talking about Asana, that project management powerhouse that keeps teams aligned and tasks on track. But here's the burning question that's been gnawing at developers, tech enthusiasts, and frankly, anyone curious about the tech stack of modern web applications. What language fuels this productivity machine? We've all been there. You're juggling deadlines, coordinating team efforts, and trying to keep your sanity intact. Then you stumble upon Asana. It's clean, intuitive, and seemingly effortless. But behind that sleek interface lies a complex ecosystem of code, architecture, and engineering brilliance. And today, we're diving deep into the core of that ecosystem to uncover the programming language that makes it all tick. Before we get to the core language, let's paint a picture of Asana's evolution. It wasn't always the feature-rich platform we know today. It started as a tool within Facebook, designed to improve internal productivity. Yes, Facebook. That's a crucial piece of the puzzle. Imagine the scale, the complexity, and the sheer volume of data they were dealing with. They needed a solution that was not only robust but also scalable. And that need shaped the very foundation of Asana. Think about the challenges of building a collaborative platform. You're dealing with real-time updates, multiple users interacting simultaneously, and a complex data model that needs to be both flexible and efficient. You need a language that can handle concurrency, manage complex data structures, and deliver a smooth user experience. This isn't just about building a website. It's about building a dynamic, interactive workspace. Now, let's talk about the tech stack. Asana is a web application, which means it relies on a combination of front-end and back-end technologies. The front-end, what you see and interact with in your browser, is built using a combination of HTML, CSS, and JavaScript. These are the standard building blocks of the web, and they're essential for creating the user interface and handling client-side interactions. But the real magic happens on the back end, the server-side logic that powers the application. This is where the core language comes into play. And the answer, the language that forms the bedrock of Asana's backend, is Python. Yes, Python. You might be thinking, Python? Really? But consider this. Python is known for its readability, its powerful libraries, and its ability to handle complex tasks with relatively little code. It's a language that prioritizes developer productivity, which aligns perfectly with Asana's mission to enhance team productivity. But why Python? What makes it so suitable for a platform like Asana? Let's break it down. First, Python's ecosystem is incredibly rich. It boasts a vast collection of libraries and frameworks that simplify development, making it easier to build complex applications. For Asana, this means access to tools for handling web requests, managing databases, and implementing real-time updates. Frameworks like Django and Flask provide a solid foundation for building web applications, and they offer features that are essential for scalability and maintainability. Second, Python is known for its readability and simplicity. This makes it easier for developers to write and maintain code, which is crucial for a large and complex application like Asana. It also contributes to faster development cycles, allowing the team to iterate and improve the platform quickly. Third, Python is highly scalable. It can handle large volumes of data and traffic, which is essential for a platform that serves millions of users. Asana needs to be able to handle peak loads and ensure that the application remains responsive and reliable. But it's not just Python. Asana also leverages other technologies to enhance its functionality and performance. For example, they use databases like PostgreSQL to store and manage data. They also employ caching mechanisms and other performance optimization techniques to ensure that the application remains fast and responsive. Let's delve deeper into the specific ways Python is used within Asana. Python plays a crucial role in handling API requests, processing data, and managing the application's logic. When you create a task, assign it to a team member, or update its status, Python is working behind the scenes to ensure that these changes are reflected in real time across all users. Python's ability to handle asynchronous tasks is also essential for Asana's real-time collaboration features. When multiple users are editing a project simultaneously, Python ensures that changes are synchronized and displayed accurately. This requires a robust system for managing concurrent updates and preventing data conflicts. Furthermore, Python is used for data analysis and reporting. Asana provides users with insights into their projects and teams, allowing them to track progress and identify bottlenecks. Python's data analysis libraries, like Pandas and NumPy, make it easy to process and visualize data, providing users with valuable insights. Now, let's address the question of scalability. Asana has grown significantly since its inception, and it needs to be able to handle increasing traffic and data volumes. Python's ability to scale horizontally, by adding more servers to handle the load, is crucial for ensuring that the application remains responsive and reliable. Asana engineers have also invested heavily in optimizing the application's performance. They use caching mechanisms, database optimizations, and other techniques to ensure that the application can handle peak loads without sacrificing performance. This requires a deep understanding of Python's performance characteristics and the ability to identify and address bottlenecks. It's also worth noting that Asana's engineering culture plays a significant role in its success. They prioritize code quality, maintainability, and testing, which contributes to the stability and reliability of the platform. This culture is reflected in their use of Python, a language that encourages clean and well-structured code. With that said, thanks for watching, and until next time.